Good morning, good afternoon, good evening, whenever you may be. It's time for another exciting adventure in science here at ACE Academy. I hope everyone had a fantastic weekend and will continue to have fantastic days going forward. Hey, guess what? We are getting closer and closer and closer to the end of quarantine, at least as they have it planned now. But as we keep going, we will continue on with 7th grade science here. So today, we're wandering into Earth system's front. So last time we talked about air masses and how air masses move. Well, now we're going to talk about fronts. Well, fronts. We're going to first define what a front is. So what is a front? Well, a normal conversation, the front is the portion of an object moving that is leading, such as the front of a train. Stationary objects is the portion that is meant to be viewed first, such as the front of the house. In one of the terms, the front is the leading edge, is a moving object after all. Let's go ahead and highlight this definition. A front is the leading edge of an air mass, of a moving air mass. Remember from the last session that air masses are large parcels of air that have characteristics different from the air around them. Air masses tend to be very large, covering many states in size. Remember, air masses are big. So when an air mass moves, the conflict at the junction between the mass that is pushing and the mass that is being pushed is called a front. Fronts are where the majority of the severe weather takes place if one is outside the tropics. There are 4 different types of fronts that we need to be familiar with. The first is a cold front. A cold front is where a mass of much lower temperature air is moving. Cold fronts move faster than other types of fronts. Cold fronts are depicted on weather maps with a blue line with triangles on it, as you see right here. Remember, this is one of those things that you have to know. This piece right here. You have to be able to look at this and go, oh yeah, that's a cold front. Which way is it moving? That. In the direction of the arrows. It is moving in the direction of the arrows. That way. Now, when cold fronts move, the direction the arrows are pointing. See, here's the cold front right here on this map, this little 3D depiction. See that blue line with the triangles on it? It's moving that way. So as the cold front moves, remember they're denser than the air they're replacing. So here's the cold air mass over here. It is denser, so it is down closer to the ground. There's the arrow showing it's moving. It's going this way. And so the air in front of it is warmer. It's replacing it. And so when it replaces it kind of as a wedge here with the pointy end down here in the direction it's moving at the leading edge. With a wedge, remember what a wedge does? It lifts heavy things, right? Or splits things in half. Well, in this case, it's lifting something on the front of the wedge. It's lifting the warm air that's in front of it. And remember, when warm air that contains more moisture than cooler air, warm air can contain more moisture. As that warmer, moisture-rich air rises, it cools and condenses in the clouds, and as more is forced up, it produces rain and lots of times thunderstorms. So you hear that, you see that depiction right here. So that warm air is being lifted up. And as it gets lifted up, it starts forming clouds here at the dew point. So that flat edge of those clouds right there. Below that, it's just water vapor. Above that, it's condensing out and starting to form clouds. And as you force more of it into this, here's your thunderstorm, a cumulonimbus cloud here, producing a lightning, a thunderstorm here inside the cold air. So now, one of the other things you want to notice is here's that cirrus cloud. So one of the times you see cirrus clouds, it's kind of an indicator of things coming, an indicator of a change of weather, because as this warm air is pushed like this, the wind at the top blows it over and blows that moisture off the top of that thunderstorm way out in front of that front. It kind of gives you some cirrus clouds out front. And that kind of gives you a weather predictor built into those little cirrus clouds. So cold front moves in, forces that warm air to rise. The rising warm air has the water vapor in it. The water vapor condenses as it cools off, because you go higher in the atmosphere. Even though, again, just because it's rising, I mean, that warm air still is warmer than this cold air mass below it. There's still a front here. And it causes that water to condense out and form storms. Next is a warm front. A warm front is a mass of warm air pushing a cooler air mass in front of it. Warm front is denoted by a red line with half circles on the red map, on the weather map. There's the half circle line right there. And then it produces things like this. So as warm air pushes along, it pushes cold air, cooler air out in front of it. Now, the one thing about it is, again, you have that wedge. There's the wedge. It's kind of reversed this time because, again, there's the front right there with the line with the little half circles on it. The half circles face the direction of travel, which is that way, and pushes that front along. But again, the warm air kind of overrides the back of this, mass of cold air. So what we run into here is that you don't really get so much the thunderstorm action because of it's a little less dramatic when a warm front pushes a colder air mass in front of it. You still get that rising air. That air is overriding and pushing up over the top of that cold front. So you still get that warm moist air rising, and you end up getting nimbostratus instead of cumulonimbus. And if you remember from the types of clouds thing, nimbostratus are a solid overcast layer of just rain clouds. So whereas the cold front coming in gives you thunderstorms briefly and quickly, a warm front moving in gives you a much larger band of just general rain producing clouds, nimbostratus. So then you'll have some altostratus, cirrostratus, and then again cirrus clouds way out in front. So again, those little cirrus clouds, when you start seeing them, usually depict a change in the weather of some sort. Now, depending on what this, in both instances, the water is falling through the cold air mass. And depending on how cold that air mass is, that's where you might get some snow or some ice or something like that. Now, the next type of front we're going to talk about is the stationary front. The stationary front is depicted on a weather map as the warm front chunk with an interspace with the cold front chunks, but the things are pointing in different directions. The bubble is pointed this way, the arrow is pointed that way, and it alternates. Stationary fronts where two air masses are meeting, but for many different reasons, they're not moving. Typically, stationary fronts are between air masses where the air temps are not vastly different. But like most things, that is not always the case. Stationary fronts don't last forever, and usually another air mass forms and finally pushes the two slow movers out of the way. But typically on a stationary front, you do get some squall lines, some occasional light rain, but not much. It's not a dedicated rain event like this, and you certainly don't get the thunderstorms like that happens here. It's just some light squalls. And lastly, there is the occluded front. The occluded front is represented by a purple line with arrows and half circles pointing in the same direction. Cold fronts typically move faster than warm fronts. Sometimes they can catch up to warm fronts. As they do, the warm front is forced up by forming an occlusion. The surface location of the occluded front is directly below the convergence point of the warm, cool, and cold air masses. So it's not too cold and a warm. It's not too cool and a warm. It's a cold, a cool, and a warm. Typically, you got to have one of each to have an occluded front. Occluded fronts point to a decrease in intensity of the parent weather system. So it's kind of running out of energy, as you might say. While there's no difference in how they're depicted on the weather map, there are two types of occlusions: cold and warm. So again, here's an occlusion. So here's basically what used to be a warm front and a cool front. Then you have a cold front moving in, replacing the warm front. The warm front overruns the warm and pushes the warm up. So you have a cold occlusion where the cold air is the one forcing everything up. And then you have a warm occlusion where it's the cool air is the trailing mass. I would say the trailing mass, the one coming from behind is the trailing mass. And you have a warm occlusion where the cool mass is the one the trailing air mass. So warm occlusions occur when the air associated with the cold front is actually not as cold as the air masses associated with the warm front. Warm front Warm air is forced up as before, but the colder, denser air mass ahead of the warm front remains at the surface, forcing the air mass associated with the cold front up as well. So this cooler air, remember, colder air, more dense. This cool is not the same as cold as this one, so it's going to ride up as well. Within this situation, the warm air is forced upwards, and when that happens, you usually get some sort of precipitation. So again, warm air has got most moisture of all three of these things. It's forced upwards. Now again, this is all happening at the tail end of some sort of storm system. So the energy is not as great, but the warm air will contain warm air. Ooh, got the yawns this morning. The cool air will the warm air will contain more moisture than the rest of the other two air masses, and as you force it up, it will precipitate out in some form. Maybe not, in storms, but it will give you a little bit of rain. But that's a occluded front. So, and that's like I said. So with either situation, warm air is forced upwards, and when that happens, you usually get some form of precipitation. So, warm occlusion, cold occlusion, occluded fronts, and stationary front, warm front, cold front. You know what it looks like on a map. You need to know what happens weather-wise. Cold fronts produce the worst weather, thunderstorms. Warm fronts, just generally overcast and rainy. And occluded fronts, you could get all kinds of things happening here, but typically, again, it's on the tail end of a storm system, so you're going to get some rain, but not too much. If you have any questions or anything, please drop me a line. Remember, if you had to contact me for any reason whatsoever, please, don't hesitate to give me a call, 704-363-9034, or text me. Again, same number, 704-363-9034. Please make sure you like the video, make sure you subscribe to the channel, and make sure you say, hey, check in the comment section. That way I know you're here. I want everybody to have a great rest of your day. And once again, signing out from a location unknown to you.